Okay, so today we're going to talk about scatter plots. All right, so we're going to construct a scatter plot and we're going to analyze trends in scatter plots. So the graph shows the percentage of people ages 18 to 29 that have used the internet in the United States over several years. So we can take a look. This is a scatter plot. Okay. All right, we have percent of population. This is the y-axis on a scatter plot. This is the x-axis on a scatter plot. We can take a look at the trend and see if there is a trend even. So do we see a trend? Well, you should see a trend that it's going in a positive direction. If a scatter plot's going up, it's in a scattered direction. So what we could see is as the number of years increase, the population increases, okay? And then it says predict what percent of people 18 to 29 that are internet users in 2020. Well, we can look at 2009 and we can see that it's about 92%, okay? So in 2020, which would be 11 years later, if this trend happens, we're going to be way up here close to the 100%. So you could say something like about 98%. And then, do you think the trend will continue? And explain your reasoning. Well, you should take a look at that and you should say, yes, based on the data, that it's going in a positive direction upward, it should continue. The other thing is you could say, to think about is that more and more things are on the internet. For example, what we're doing right now. You guys are watching this video on the internet. So yes, the trend I believe would keep going up. All right, so to construct scatter plots, a scatter plot shows the relationship between a set of data with two variables graphed as ordered pairs on a coordinate plane. Okay, so bringing together some things that we've already learned in this chapter. So make a scatter plot of approximate population of the Tampa of Florida. So we have our data. This would be our X. This is our Y. We make a scatter plot. So in order to make a scatter plot, we would draw a coordinate plane, okay? The population would be my Y, so I would write it up this side. And my year would be my X, so I'd write it down on this side. And then as far as the numbers I use, just look at your data on how it is, and then judge what numbers you would use that all your data would fit between, okay? And then just plot it. So 1940 and 108. So this is 1940, that's about where 108 would be, and plot it. 1950 and 125. Again, this is where 1950, and this is about where 125 would be. And you could continue on and put all of those points in, and this would be your scatter plot. Okay? All right. So here's an example. You can pause and try this. Come back, see how you did. This is on your notes. All right, so it says the table below shows the fat grams and calories for several snack foods. All right, so here is my table of all my information. So I am to make a scatter plot of the data in the table. So I can draw out a scatter plot, which would look like this or similar to this. Fat would be my X, and Y would be my calories, okay? Because the number of calories are dependent upon how many fat grams you have. So then we would plot that. We would say 13, so it would be a little past 12, and 306. So it would be about right here. Now you will see that that's not even on a line, which it doesn't have to be. It's where the information's supposed to go. Then we have 13 and 200. That's going to be about right here. Okay. Then we have 3 and 150, which would go here. Then we have cake, which is 13 and 230. So it's going to go about here. And then we have snack crackers, which is 6 and 140, so about here. Then we have ice cream, which is light ice cream, which would be at about the 5 and 130 range, so right in here. Then we have yogurt, which is 2 and 70, which would be right in here. And then we have cheese pizza, which is 18 grams of fat and 410 calories, so about here. Okay? So that would be my scatter plot. And one thing you would notice is that it's going up, so it's a positive trend. And if I had to explain it, I would say as the number of fat grams increase, the number of calories increase as well. Okay. Talking about positive and negative scatter plots, we have 3 types of scatter plots that I want you to look at. One is the positive, when all of your points can be looked at as in going up, okay? That means X increases and Y increases, okay? So X increases and Y's increase. If your points look like this, to where you can pretty much do this, that is a negative increase. As X increases, Y decreases, okay? And then if you have a scatter plot that looks like this, there really is no relationship. It's not going up or down, okay? So this would be no obvious pattern. It would be no relationship, okay? So we have positive relationships, negative relationships, and no relationships. If we look at this, it says determine whether the scatter plot of the birth month and age of people in a park might show a positive, negative, or no relationship. Explain your answer. All right, explain your answer. So we take a look at this, and are we showing positive, negative, or no relationship? All right, well, there really is no relationship. It's not positive or it's not negative. So in other words, the month that you were born in has no bearing on the age or the year, okay? So I could say a person's age is not affected by their birth month, okay? And it would be no relationship. So let's take a look at these. It says, determine whether a scatter plot of the data for the following might show a positive, negative, or no relationship. Explain your answer. So we don't really need, in some cases, the scatter plot to figure it out. We could think it through. So number 1, fat grams and the amount of calories in food. Well, think about it. As fat grams move up, the calories went up, remember? So that would have been a positive relationship. And then number 2, time spent relaxing and blood pressure levels. Well, in life, and when you relax, your blood pressure goes down, right? So that would be a negative scatter plot if we plotted data for that. And we could say relaxing lowers blood pressure levels. And then the age of a child and the number of siblings. If you think about it, the number of siblings is not affected by the child's age, okay? Just because you're a certain age doesn't mean you have a certain number of brothers and sisters. So there would be no relationship. And then the age of a tree and its height. Well, the older the tree, the taller it can grow. So that would be positive. The age of the tree does affect its height, okay? All right. Slide 9. You can also use scatter plots to spot trends, draw conclusions, and make predictions about data. So for example, the table shows how many cups of coffee were sold during outdoor games at certain temperatures. So here's my data, okay? I have number of cups of coffee and temperature. First thing I do is make a scatter plot. So I would make a scatter plot. I would put temperature at the bottom, and I would put cups on the left side, or the Y. And then I can number that however I want to. I know if I look at temperature, my lowest one is 34, my biggest is 75. So I could go like they did and start and do 35, 40, 45, 50. So I could go by fives. And then the temperature, that's how I would do temperature, 0, 5, 10, 15, 20. And then number of cups of coffee goes all the way from 8 to 42. So I could do the same thing with fives. And then I plot. Temperature again is my X. my number of cups is y. So 34 and 42. So 34, 42 would go right here. Okay? And then I would continue to plot all of my points. Then it says draw a conclusion about the type of relationship of the data shows, and then explain. Don't forget to explain. Don't just put negative. If I look at this, it's a negative, or it's going down, so it's a negative relationship. And I can say as the temperature increases, the number of coffee sold decreases. Okay? And then predict the number of cups sold if the temperature was 30 degrees Fahrenheit. So we know what it is at 34 degrees Fahrenheit. So we could just go to the left a little bit, and what would it be? Well, it would be somewhere between 40 and 45 cups. Okay, it'd probably be closer to 45. So I could put between 40 and 45 cups will be sold. I could put about 44 cups would be sold, somewhere in there. Okay, all right. So here's an example, and you can try this and then come back. It says the table shows keyboarding speeds in words per minute of 12 students. It gives you a table. It gives you the experience and the speed, okay? So X and Y. And then it says make a scatter plot of the data, draw your conclusion about the type of relationship the data shows, and then predict the keyboarding speed of a student with 12 weeks of experience. So I happen to do that already. This would be your scatter plot, or what it should look like. And you will notice that after you plot your data, you can kind of see a trend forming, right? Should be a positive relationship is what you should have gotten. So as experience increases, the speed increases, and that should make sense. The more experience you have, the faster you'll be. Okay, and so I could state as students' experience increases, so does his or her keyboarding speed. And again, it's a positive relationship. And then to predict at 12 weeks, I know what it is at 10 weeks. So I come over here to, that would be 11, come over here to 12 weeks, and I take a look at what it would be, and I know it's probably going to be somewhere around 60, just a tad bit higher than 60. So I could say 62, 63, somewhere in there would be okay. Okay? So again, it's just a prediction following the trend. All right. If you have any questions, please let me know. I'd be glad to help you out. Other than that, your homework's posted. All right. Have a great day.